Hi guys and girls, a video here on hypothesis tests to do with correlation of a sample rather than the mean of a sample. They will assume that you have met correlation before in year 12, and they will assume that you know that correlation can take a value between positive and -1. If you're not sure what that means, go back to year 12 and revisit it, basically. So basically the idea behind this is it's quite difficult to know when weak correlation becomes strong correlation, and it can be quite wishy-washy, and often it depends on how many things are in your sample and also the kind of the significance level, how sure you want to be your conclusions are accurate. So they have a test, basically, hypothesis test. And what they do is a sample population, what am I about sample population? Sample correlation is R. Forgot how to spell correlation there. But a population correlation, don't say that with a mouthful, is that. It's not a P, it's rho. It's kind of like an italic P, if you like. And what it tests, it's whether it decides if rho is equal to 0, basically. So your null hypothesis is saying that there's no correlation between the things you're measuring. Your alternative hypothesis is that there is, and that could be one tail or two tail. And you use critical value tables, which are provided to you in the exam or in the back of a textbook or on a website. They'll be there somewhere, and I'm going to show you how to use those as well. Now, the key piece of information is if the modulus of R is bigger than the critical value, you reject the null hypothesis. So there is a correlation between whatever it is you're measuring. So those four things are kind of really all you need to know. I've only got a couple of examples. It's really not a difficult concept. So the first one. So we are told that the correlation, sometimes they might call it the PMCC, which is product moment correlation coefficient, which is how correlated they are, between height and weight of 10 people is 0.73. So is that strong enough? It's a fairly strong correlation, but is it strong enough to say, yeah, there's definitely a correlation between height and weight? So, are the weights, or height and weight, oh Lord, it's a problem with trying to write quickly, positively correlated at the 5% significance level. Let's shorten that to sig. Well, H0 says that rho is 0. H1, we know that this has got to be positively correlated, so rho has got to be greater than 0. We know that there are 10 people in our sample, and we know that the significance level I'm going to short to SL, is 5%. And it's a one tail because we've put a direction on row rather than just saying that it's not equal to 0. Critical value tables then. So I'm going to use the ones off of the Cambridge Elevate website. And to get to it, if you're using this website, you go to Contents, all the way down, pretty much down to the answers. There's one there called Statistics, and they all look like this. So, we want a one-tailed test at the 5% significance level. And then n is how many are in our sample, so we need to go down to where n is 10. There. 5494 it says under there. So the critical value oh, I've lost my pen. Sorry, my pen just went a bit nuts there. Critical value from the table we've said is 0.5494. Now the condition was if the modulus of R is greater than the critical value, reject the null. So the modulus of 0.73 is just 0.73. That is bigger than our critical value. Therefore, we reject H0. So with the question being, are the height and weight positively correlated? So we say yes, since 0.73 is greater than 0.5494, we reject H0, and then put it in context. Height and weight are positively correlated. Relate it back to the question. At the 5% significance level. That's it. It's knowing how to read a table. So one more for you. We have a sample of 30 people. I'm probably going to shorthand this one. So we've got a sample of 30 people. And it's test scores. And we are told that the p-value, that's p not rho, is 0.00192. So that's all we're given. Oh, apart from the significance level. So the question is there evidence at 1% sig level to suggest a correlation? So we know H0 says that rho is 0. We know that H1, in this case, is going to say rho is not 0. So that means it's going to be two-tail. We know n, we know 30. So we can look up the critical value. Let's go back to my tables. So this time, if I go up to the top, let me go back up to the top. We're doing a two-tailed test. If it's two-tail, we have to half the value. No, we don't. I tell a lie. You do on a normal mean hypothesis test, but this is already built into this table, so you don't need to. But we are going down to where n is 30. There's my little draggy thing. It's going to be a long scroll. So n being 30, we want that one there. So 4629. So 0.4629 is our critical value. But we're not comparing it to the p-value. The p-value is the probability that x is less than or equal to something. That's got to be equal to 0.00192. And all of these things, these hypothesis tests, are assuming normal distribution. So what we're going to do is we're going to do the inverse normal. So the inverse normal of 0.00192 is z. So you've got to remember z values as well, which is negative 2.889. Now that's all come from my inbuilt calculator function. So I've gone to my distributions, gone to inverse normal, set my area to be 0.00192, and my n was 30. And I've also assumed that it's a standard normal, so I've assumed that it's distributed normally with sigma being 0 and, mu being 0 and sigma being 1. Anyway, you get negative 2.889 from that. Now you've got to turn your z value into a x value. So z is x minus mu. Don't know why I've done a capital there. Doesn't matter. X minus mu over sigma. Because it's a sample, then it's over root n as well. Because you're doing, oh Lord, sigma over n. That's the distribution you're actually following. With that, we know 2.889 is something minus my assumption is 0 and 1 over root 30. Either anyway and how you rearrange that, you end up with x being 0.527. Yep, that matches my notes. I was just double checking. So the modulus of the x value, it's actually r really, I suppose. The modulus of that is that with no negative on. Alright, and that is that more or less than our significant value. Our critical value. Well, our critical value was 0.4629. So that is greater than 4629. Therefore, we reject H0. And then we put it into words. So since 0.527 is greater than 0.4629 at the 1% sig level, reject H0 and then put it in context. So there is evidence to suggest a correlation between test scores. Always relate it back to the question. See you later.